Welcome to the video for the model question for C5.3. So this question's talking about the reversible reaction where carbon dioxide reacts with hydrogen to make methanol. It gives you the equation here, so that question mark is just an error in the transfer. It should be an arrow, except it's a reversible arrow, isn't it? So it should be one of those. So Phil investigates this reversible reaction. He mixes carbon dioxide with hydrogen. He lets this mixture reach equilibrium. Phil measures the percentage yield of methanol in this equilibrium mixture. He uses different temperatures and pressures. Look at his results for different temperatures at a pressure of 100 atmospheres, and then look at his results for different pressures at a temperature of 400 degrees C. How does the percentage yield change with temperature and with pressure? So we've got to see how it changes with temperature and how it changes with pressure. So let's just circle those so we don't forget. And then describe how the percentage yield is linked to the position of equilibrium. So let's look at this table first. So in this table, we can see as we go down the table, we are increasing the temperature. And when we've done that, what's happened to the yield is the yield's gone down. So the percentage yield has decreased. And then when we look at the pressure, as we go down the table, we've increased the pressure. And when we've done that, we've seen that the percentage yield has increased. Now, this makes sense when we look at the reaction because these are all gases. Methanol's a liquid and water's a liquid. So we've got more moles of gas on the left-hand side. So as we increase the pressure, it will push the equilibrium to the right and we'll get more yield. But this question's not asking us to explain that, so we don't need to worry about that. So how does the percentage yield with temperature? So we'll do that bit first. So what we need to say is when we're describing a trend, we always say as the something either increases or decreases, the something else increases or decreases. So as the temperature increases, the percentage yield, and I'm going to write percentage instead of giving the symbol because it's one of these quality of written communication. So I need to write in full sentences. So the percentage yield decreases. And this means we're making less methanol. So this means we are making less methanol. So that's the temperature done. And then the pressure. So as the pressure increases, so the percentage yield, in this case, it increases. This means we are making more methanol. Right, and then describe, so we've done the pressure as well. So now we need to describe how the percentage yield is linked to the position of equilibrium. So if we remember, so I've run out of space here, so I'm going to rewrite this equation here. So we have a forward and a backward reaction. So the position of equilibrium describes the ratio of the products to the reactants. So if the position of equilibrium is to the right, then we're making more products. So the percentage yield will increase. If the position of equilibrium pushes to the left, then we're going to make more reactants, so we're going to have less products. And we're going to have a lower percentage yield. So we need to write this in full sentences. So the position of equilibrium describes the ratio of reactants to products. If the position of equilibrium is on the right-hand side, then there are more products compared to reactants. This means the percentage yield is higher. And then we need to write out the converse for the position of equilibrium being on the left. So if the position of equilibrium is on the left hand side, then there are less products compared to reactants. This means that the percentage yield is lower. And now I've done that, describe how the percentage yield is linked to the position of equilibrium. So I've answered all the questions now. Okay. Thank you for listening. See you next time.